let's do another 3 by 3. So let's just pick a row or column to expand along. I don't see anything that's particularly easy. Maybe I'll just use this middle row for the sake of having some variety here. Remembering our checkerboard, this is in a plus position, so the 3's in a minus, the 2's in a plus, and the 5's in a minus position. So we have negative 3 times the determinant of the 2 by 2 you get when you cross out the row and column that the 3 is in. That should leave 3, 2, negative 4, 2. So 3, 2, negative 4, 2. The next one is the 2, and it's in a plus position, so I won't mess with its sign. I'll multiply it by the determinant of the 2 by 2 you get when you cross out the row and column that the 2 is in. So that's just crossing out that center row and that center column. You have 1, 2, 1, 2. Okay, and then finally the 5 is in a minus position, so we have minus 5 times the determinant of, let's see, what's the little 2 by 2 I get here? Cross out the column and the row that the 5 is in, and we get 1, 3, 1, negative 4. 1, 3, 1, negative 4. So with a little work here, we have 3 times, what is this? 3 times 2 is 6. 2 times negative 4 is negative 8. 6 minus minus 8 would be 6 plus 8. Plus 2 times 2 minus 2, that's 0. And then minus 5 times, we have negative 4 minus 3. Product down to the right minus product down to the left. Okay, so we have negative 3 times 14 plus 2 times 0 minus 5 times negative 7. So 3 times 14 is 42, so we have negative 42. Oops. Negative 42 plus 0, and then negative 5 times negative 7 is plus 35. So we get negative 7. That means if you were to make a box whose sides are parallelograms from these 3 vectors or arrows, that the volume of that box would be 7. And it doesn't matter what row or column you expand along. We could have just as easily, let's do this one. Let's expand along that bottom row and see that the answer is the same. Again, the checkerboard is always plus in the upper left, so you have plus, minus, plus. So the 1's in a plus position, the negative 4 is in a minus position, and the 2 is in a plus position. So we have 1, since 1's in a plus position, I won't mess with its sign, times the determinant the determinant of the matrix that's left over when you cross out the row and column that contain that 1. And then the minus 4 is in a minus position, so I'll flip its sign, it becomes positive 4, times the determinant of 1, 2, 3, 5, like that, and then plus 2 times the determinant of 1, 3, 3, 2. So let's see, we get 1 times 15 minus 4 plus 4 times 5 minus 6 plus 2 times 2 minus 9. And let's see, 15 minus 4 is 11. 1 times 11 is 11. 5 minus 6 is negative 1, so we get minus 4. 2 minus 9 is negative 7. 2 times negative 7 is negative 14. So we have 11 minus 18 equals negative 7. Same answer again, right? So it doesn't matter what row or column you expand along. Last example here, let's do a 4 by 4. And this is kind of a special 4 by 4 matrix. Notice that we could call it a tri-diagonal matrix because it has only 3 diagonals that are non-zero. Also, this matrix is symmetric, which is to say if you take the first row and flip it, it becomes the first column. The second row, if you were to flip that around this main diagonal down, you'd get this, right? So it's a symmetric matrix because when you transpose it, when you switch all the rows and columns in order, the matrix looks exactly the same. We just need to pick a row or column to expand along. the most entries we can have in any row looks like 2, right? So, the most entries is 3. The least entries is 2, so we just pick a row that has the most non-zero entries. This might be, I just picked a column. Okay, so we'll take that column. The 2 is in a plus position, the 1's in a minus position. So since the negative 2 is in a plus position, I won't mess with its sign. And it's negative 2 times the determinant of what you get when you cross out the row and column that negative 2 is in, which is negative 2, 1, 0, 1, negative 2, 1, and 0, 1, negative 2. Okay, and moving on down, we had a plus 1, but it's in a minus position, so I'll flip its sign and make it negative 1 times the determinant of what's left when you cross out the row and column that the 1 is in. Let's see, I get 1, 0, 0, 1, negative 2, 1, and 0, 1, negative 2. Okay, so we've reduced finding this 4 by 4 determinant to finding 2 3 by 3 determinants. Now I just have to calculate both of those 3 by 3 determinants. For this first one, let me expand along this first column. So I'll have negative 2 times the determinant of what's left when you cross out the row and column that the negative 2 is in. So negative 2, 1, 1, negative 2. The 1 is in a negative position. Remember, the checkerboard is plus at the top left, so this is in a negative position, so flip its sign. And you have times the determinant of 1, 0, 1, negative 2. And then minus 1 times this determinant. Let me expand along this upper row because that has the fewest non-zero entries. 1's in a plus position, so I just have 1 times the determinant of negative 2, 1, 1, negative 2. The rest don't matter, right? Because 0 times that subdeterminant, or 0 times this subdeterminant, is going to just be 0 anyway, so I don't need to calculate it. Okay, so we have negative 2 and negative 2, and this determinant is 4 minus 1. And then we have negative 1. This determinant is negative 2 minus 0, so just negative 2, basically, minus 1 times, let's see, this determinant is 4 minus 1. Okay, almost there. We have negative 2. 4 minus 1 is 3. Negative 2 times 3 is negative 6. Negative 2 minus 0 is negative 2 times negative 1 makes plus 2. And then we have 4 minus 1 is 3. 1 times 3 is 3, so we have minus 3. So negative 2 times negative 6 is 12. Plus 2 minus 3 equals 11. Okay, this also has an interpretation as if you lived in 4 dimensions, then you could have arrows that had 4 directions in which to go, and you could make these interesting 4-dimensional boxes, and this would be the volume, or rather hypervolume, of a 4-dimensional box. Okay, try not to think about that. Okay, we'll use this though, especially for 2 by 2 matrices to find areas, and for 3 by 3 matrices to find volumes.